Hi guys, and welcome to another video. Today we're going to be looking at lines, angles and triangles. Now in this lesson we're going to cover angles on a straight line, we're going to cover parallel lines and the properties of triangles. Now if you are a little bit sketchy in those particular sections, then my advice would be just go and do some light reading and summarize that particular section and practice with a few examples, and then come back to this particular section. Remember, the best way for you to answer these questions or to get the full benefit of my videos and questions is for you to pause the video at the very beginning, answer the question yourself, and then press play afterwards to see whether our thinking is the same. So once again, we need to, R is for read, so we will read up on lines, angles and triangles. Then we would make a summary of all the information, and then we would just practice with a few examples, and then we come back and answer this particular question. Now, if you've already done that, let's look at the question. It says, in the figure below, AB is parallel to DE. Now remember that this is the symbol, an arrow on the line means that these two lines, AB is parallel to DE. ACD is equal to 95 degrees. ACD, so this angle is equal to 95 degrees, and CDE is equal to 30. CDE is equal to 30 degrees. Now our first question says, calculate with reasons the size of C1. So let's go look at C1. And there we go, that is C1. So if you've read, summarized and did a little bit of practice, you will know that angles on a straight line add up to 180 degrees. So angles on a straight line are supplementary. The word supplementary means they add up to 90, or rather 180 degrees. So therefore C1 is going to equal to 180 minus 95 degrees, and our reason will be straight line, or we can say supplementary angle. Once again, supplementary angles add up to 180 degrees. So our solution will be 180 minus 95, and that's equal to 85 degrees. 85 degrees. So let's look at what we've done already. So we've looked at the concept of a straight line, and we know that straight lines add up to 180 degrees. Angles on a straight line are supplementary. Let's look at the next question. In the next question, we asked to calculate the size of E with reason. So one thing that you must take note of in geometry is always update your diagram. So C1 is equal to 85 degrees. So that's 85 degrees. Now they want us to find E. So looking at E, E is in the triangle CED. So now we're going to look at the property of this particular triangle. And what do you know about the sum of angles of a triangle? Well, they add up to 180 degrees. So therefore E is going to equal to, let's look at it once more, 180 minus 85 plus 30, or we could say 180 minus 85 minus 30. Sum of angles of a triangle add up to 180 degrees. So E is equal to 180 degrees minus 85 plus 30 degrees. Sum of angles of triangle. And that's our reason, statement and reason. And let's put that in our calculator just to assist us a little bit. 180 degrees minus 85 plus 30 equals 65 degrees. So the size of E is 65. Now let's look at if there was another way that we could have found E. So we say 65 degrees. So our second one, we're looking at the properties of triangles in our second example. So let's look at it once more. Could I have found 65 in or the angle E in another way? Yes, I could. If I look at this ACD, it is an exterior angle to triangle CED. And what do we know about an exterior angle of the triangle? The exterior angle of the triangle is equal to the sum of the interior opposite. So 95 minus 30 would give me 65. Let's look at the third question. Now in the third question, it says that we must calculate the size of A. So there's angle A. Let's go locate it. And there we go. There's A here. Now let's look at A. Remember, we've updated our diagram. So we've given that AB is parallel to DE. And if you can look very carefully, the third concept that we're going to be looking at here is parallel lines. And remember that when we're given parallel lines, we need to look for our fun angle, which is F stands for corresponding. And remember, corresponding angles are equal. U is for co-interior angles, and co-interior angles are supplementary. N, or your Z shape. N, if we want to spell fun. N is for alternate angles. So if we look here, we have a relationship that we can look at from our fun angles, and that would be the U shape. The U shape. Remember, the U shape doesn't necessarily have to look like the letter U in the alphabet. It can look in any direction, or it can be formed in any direction. So there's my U shape here, and if you look at it, A and E are co-interior angles. And what do we know about co-interior? They are supplementary. So therefore, I can find A by saying 180 minus, supplementary means add up to 180. That means angle A plus angle E must equal to 180. So A is going to equal to 180 minus 65 degrees. So 180 degrees minus 65 degrees. And the reason that I'm going to give there is co-interior angle. And when you use any reason dealing with parallel lines, for example, corresponding, co-interior, and alternate, you must state the pair of parallel lines. So I'm also going to write AB parallel to D. So next to that, I'm going to write AB parallel to D. And 180 minus 65, 180 minus 65 equals to 115 degrees. And there you go, learners. A is equal to 115 degrees. 115. Now remember, the key thing for you to remember and to do is to make sure that you update your diagram, that you interact with your diagram if you are going to be good in Euclidean geometry. Once again, read, summarize, practice before you look at any question. Let's look at the next question. So in this particular question, it says, in the figure, PQ is parallel to RS. And remember, as discussed in the previous example, the symbol for parallel lines is the arrow. Q1, Q2, and Q3 are equal to 2x, 3x, and 4x, respectively. Q1, Q2, and Q3 are equal to 2x, 3x, and 4x, respectively. That means that Q1 is 2x, Q2 is 3x, and Q3 is 4x. And they also tell us that R is equal to Y and S is equal to Z. So always read your information and make sure that it appears on your diagram. So calculate the value of X. So if I go back to my diagram, what do I notice about this line TQS? Well, it's a straight line, and angles on a straight line are supplementary, which means they add up to 180 degrees. So I can now form a statement and I can solve for x. So therefore, 2x plus 3x plus 4x equals to 180 degrees. And my reason will be straight line, or I can write supplementary angles. Now learners, this is an equation where we are solving for x. 2x plus 3x plus 4x. It's like saying 2 rands plus 3 rands plus 4 rands. So 2 rands plus 3 rands is 5 rands plus 4 rands is 9 rands. So basically it's 9x equals to 180 degrees. And solving for x equals to 180 degrees divided by 9, and x will equals to 180 divided by 9 should give us 20 degrees. Because 9 times 20 is 180. So once again, x is equal to, angle x is equal to 20 degrees. Calculate the value of y. Now the value of y, so if we go back up here, so we got q1, q2, q3. We know that the value of x is equal to, so we can just leave it as x equal to 20 degrees, right? And that would be sufficient. Now let's look at the next question. It says calculate the value of y. The value of y, let's look at a relationship here. Remember they told us that PQ is parallel to RS. So if you look at it very carefully, the relationship, I can form a relationship here with y and with Q2. And what shape is that? Well, if you look at it carefully, it is the Z or our N shape. So therefore, y is going to equals to basically 3x. So this angle y is going to equal to 3x. And that is because it's alternate Q2. So that's alternate angle. So therefore, I can write a statement with a reason. So it will be y equals to 3x, and 3x, remember, is q2, so I'll just write 3x, and my reason will be alternate angles. And remember, if I'm using alternate angles as a reason, I must state a pair of parallel lines. So PQ parallel to RS, PQ parallel to RS. So from the first example, remember x is equal to 20 degrees. So therefore I will substitute x in here, 20, and 3 times 20 degrees is going to equal to 60 degrees. So therefore y is going to equal to 3x, which is 60 degrees. In the next question, it says that we must calculate the value of z. So let's look at that very carefully. So now, to calculate the value of z, and I can look for a relationship here with z, and if I look carefully, z is corresponding to q1. Therefore, z is going to equal to 2x. And there's the F shape here. As you can see, there's my parallel lines, PQ parallel to RS. So, q1 and s is going to be corresponding. That's my F shape. So I can now write my statement and say that z is equal to 2x, and my reason will be corresponding angles. And remember to write down the pair of parallel lines, PQ parallel to RS, PQ parallel to RS, and we already solved for x in the first question, so we'll substitute x equals to 20 degrees for x. 2 times 20 is equal to 40 degrees. So that's our solution to that triangle. And if we had to just double check everything here, 4 times 20 is 80 degrees, 3 times 20 is 60 degrees, and 2 times 20 is equal to 40 degrees. And what do we know about the sum of angles of a triangle? It must add up to 180 degrees. So therefore, 60 plus 40 is 100, plus 80 is 180. So everything makes perfect sense. In mathematics, everything must make sense. And in order for that to happen, we must make sure that we look at our theory in detail. So once again, please read, summarize, and practice before looking at the video. And if you haven't subscribed already, subscribe to my YouTube channel, JL Maths, and check out my videos on jlmaths.com. I'm Justin Lazarus, and I'll catch you in the next video.